Here we are. It's all the way done to video 3. We're almost done for today, with videos anyway. So we're doing percent composition and chemical formulas. Ooh, this is a fun one. We are calculating percent by mass. That's percent composition. We interpret a chemical or an empirical formula. And then maybe we'll get to this empirical versus molecular formulas, which we didn't do that page on Tuesday. Percent composition, empirical formulas of vocabulary. Mass of the element divided by mass of the compound times 100% is the percent mass of the element. So that's easy. So number one, the blank of a compound is the percent by mass. That's percent composition. Let's do green this time. So the percent by composition of a compound is the percent by mass of each element in the compound. Percent by mass of an element in a compound is the number of grams of the element per 100 grams. And we never do that. I don't know why they put that in here. Multiplied by 100. To calculate the percent by mass of an element in a known compound, divide the mass on the element in 1 mole by the molar mass and multiply by 100. That's the molar mass of the compound. Number 4, an empirical formula represents the lowest whole number ratio of the elements in a compound. If we calculate it from the percent composition, the molecular formula, the molecular formula is either the same as its empirical formula or is some whole number multiple of it. Right, the empirical formula, think of that as like being reduced. So if you have the sugar molecule C6H12O6, that's the molecular formula. The empirical formula, we would reduce that as far as we could. I would divide everything by 6, CH2O. Oh, look at that. Carbon and water. Isn't that a carbohydrate? Is sugar a carbohydrate? I believe it is. Anyway, so that's that page. Are we doing the true-false? I don't think I like these true-false. It's necessary to know the formula of the compound in order to calculate its percent composition. That's sometimes true. You mean you can do it other ways? Probably. If the percent by mass of carbon and methane is 75, then 100 grams of methane contains 25 grams of hydrogen. Yeah. The formula for methane, CH4, is both molecular and empirical formula. Yeah. And the empirical formula for glucose, C6H12O6, is C2H4O2. No. Remember, we can divide each of those by 2. So it's not the most reduced. It's not the lowest whole number ratio. It's not. Which one of these describes the actual number of atoms of each element in a molecule of a compound? I believe that's the molecular formula. And then the lowest whole number ratio of atoms in the element to a compound. The lowest whole number ratio. Isn't that the empirical formula? And then the percent by mass of each element. Isn't that the percent composition? CBA. 14% by percent composition. You are excellent at that. Do that. Empirical formula. You are excellent at that. We did that yesterday. Remember, you turn your percent to grams. Hey, you know that. Okay, that's my last snooze. And then how many kilograms of iron can be recovered from 639 kilograms of the ore Fe2O3? Let's make that one bonus. I think you can do it. You'll just need the percent composition of this, which I think you can do that. Well, then what? You'll figure it out if you're smart. So, do the rest of these. Have this packet ready to turn in. If you don't get it done today, it's homework. Oh, homework. Yeah, homework. So, good luck. And I will see you on Friday. Tomorrow, it'll be an exciting an exciting assignment for you tomorrow. You can hardly wait, I can tell. So, get some sleep.